Hello everybody, so for my microbiology report, I'm going to be presenting on tularemia. Tularemia is actually also known commonly as rabbit fever or lawnmower disease, and it's caused by the infectious agent Francisella tularensis, and that is going to be a gram-negative aerobic bacterium, so it does need oxygen. It takes the shape, as you can see here in this little image that I took from the first page. It is a broad-shaped coccobacilli, and then it is going to be an intracellular bacterium. It originates from the Francisella family, and so what's unique about that family is all other members are also going to be broad-shaped, have that coccobacilli shape, and also be gram-negative. Historically, tularemia is thought to have been tracked all the way back to Cannon in 1715 and 1075 BC. Now, on a modern note, it has been first isolated by G.W. McCoy, who was a doctor and agent of the U.S. Public Health Services, and he isolated this back in 1972. So regarding pathogenesis and virulence, so it has a high virulence rate. F. tularensis is actually very spreadable, and it actually has been found within many animals. So this includes invertebrate, fish, birds, mammals, especially that of rabbits, mice, deer, and humans, but we'll talk about that in a second. So there are various modes of transmission for this disease. So it is a zoonotic disease and typically spread by arthropodic vectors. So again, ticks, deer flies, fleas, even mosquitoes. So those are going to bite people and infect them that way by passing the bacteria that way. Or you can come into contact with an animal who is infected or contaminated with the disease. You can also ingest contaminated particles, such as dust, or when the bacteria becomes aerosolized, and so it's just floating around, and then you inhale it that way. So the most important hosts for this bacterium are probably going to be mammals. They're going to be deer, rodents, rabbits. A lot of mammals you'd find roaming in woodland areas or just wild open land. And also galliforms. So galliforms, those are going to be your heavy-set grounded birds like chickens, turkeys. They eat off the ground. The good news is that this disease can actually not be passed from human to human. A human cannot be provide a mean of transmission to another human regarding disease. And then here's a graphic just showing how sorry about that. Showing how the bacteria can be inhaled by these rodents and then passed to a dog or a cat or pet, and they come to contact with a human, or the human could actually just inhale it directly, or there are these arthropodic vectors that will come and bite you and infect you that way. So there's that. Continuing with pathogenesis and virulence. So what the bacteria actually does, it utilizes a host macrophage to prolong survival and continue the life cycle. So it actually uses the macrophage of the immune system as a incubator almost. So it'll stay there, hide there, and again, just incubate, survive, replicate really rapidly until the cell inevitably goes into apoptosis, pops, and then these bacteria come out into the cytosol. And just repeat the process again. Looking for another macrophage as a host to reproduce in. So F. tularensis is it produces a hemolytic agent to degrade the macrophage. I believe it actually does produce a few different kinds, and the bacterium does actually have ATP binding cassettes, or ABCs, possibly linked to secretion of other virulence factors. So in this image, I also took this from the beginning of my slides. It is F. tularensis bacterium infecting a macrophage, and you can see it there just replicating and sticking to the walls and growing. So symptoms and signs. Most of the symptoms actually depend on the route of transmission. So this table came from the CDC. So we have the ulceroglandular or the granular, and so these are going to be vector-borne, or when you directly come into contact with infected animal or material. You have your oculoglandular, and this is when you are infected and you have the bacterium on your eye, and then you touch it that way, or put your fingers in your mouth, something like that. Just typically the eyes. Your oropharyngeal. So this is when you actually ingest or consume the contaminated food or water. We have your respiratory, so this is just inhaling aerosolized bacterium, typically contaminated particles or dust. This is typically what happens in labs. And then we have typhoidal, which is very severe and has an unknown route of acquisition. So tularemia is actually quite dangerous. The F. tularensis, it doesn't take that many bacterium to kill you. I believe it does take approximately 10 to become dangerous enough to become fatal. 25 if you're inhaling the bacterium and letting it infect you via respiratory system. So it will attack the lymphoid system and cause swelling and pain there, lots of tenderness and just aches, and it hurts to touch it. And that's your immune response trying to create antibodies to fight off the disease. And effects of the bacterium, you're going to see severe inflammation and redness to the eyes, and then that'll spread all across the face, and then it will move to your lymph nodes, again causing sensitivity there. You will experience fevers, which typically are mild, but they can escalate if they get bad enough. Also, as you can see here, there's going to be skin lesions and ulcers. So these occur on the skin where you've come into contact with the bacterium or the animal that was infected, or if you were bitten by that vector. And finally, there's a risk of sepsis, so that's going to be infection of your bloodstream with the bacteria. Whoops. So screening and treatment. So tularemia is actually quite rare. It's often misdiagnosed because of this. So you can do serological tests. You can do an antibody count, but most times these tests are useless, or the data that comes from these are useless unless they're examined by specialty labs that specialize in screening or studying tularemia by itself. So blood tests and cultures. So bacterium can be taken from suspicious lesions or said ulcers on sites of your skin, and those can be grown in a culture and then examined by a specialist as well. Here we have an example of the F. tularensis being cultured in blood agar in this little plate over here. So there's no real safe vaccine for humans, but there are antibiotics and medication often prescribed. These include streptomycin, gentamicin, doxycycline, and ciprofloxacin. And so the symptoms and the illnesses, the terrible feelings, those can last up anything from a week to a few weeks. And despite how severe and painful a lot of these symptoms are, most patients will actually recover fully from this disease. So regarding outbreaks and prevalence, tularemia is prevalent worldwide. Most cases are reported in the US from 2001 to 2010. So just as reference, I'm using this map here. This is a map of cases reported from 2001-2010, and this is from the CDC's website itself. So most of the severe and fatal cases in the US are accompanied by details of patients being outside, hunting, hiking, or being outdoors, just exposed and vulnerable to a lot of those said arthropodic vectors and animals who are reservoirs for the disease and the bacterium. So in the US, again, between 2001 and 2010, I've put down the 4 states with the most cases. So we have Missouri, Arkansas, Oklahoma, and then surprisingly Massachusetts, which isn't in this really heavily cased area. But right after Massachusetts, I believe it was Kansas with 60-something cases, 65 or so cases. So finally, another problem with tularemia or rabbit fever is that it makes a great bioweapon, and that's because it is a non-lethal weapon that can be used on citizens. So it's not meant to actually kill, but induce suffering and cause a lot of pain and chaos. And so the bacterium can also be aerosolized. So again, it can just be laid in dirt and food and grass, brush, And as soon as it's stirred, the particles become airborne, and you can inhale them, and they can affect you via respiratory system. So it doesn't take very many bacteria to infect a person and cause a lot of harm. Anywhere between 10 to 20 to actually become fatal, and then or dangerous, and then 25 to 30 if upon inhalation. And again, there are no vaccines to treat tularemia, so just a bunch of antibiotics and then some time. And then I did include this little image. It's kind of blurry, but it is the World Health Organization's guidelines on tularemia. And it was one of my sources. It's from the CDC, or at least in working with the CDC. And it does cover a lot about the tularemia, the causative agent, what to do in case of an actual outbreak, how to handle the actual bacterium in labs, so it would help with research or if specimens are collected. And then there's my works cited. Thank you guys very much.